Last one. Yes. Yes. So Monday we have test 5. Tuesday, it's kind of just going to be open for questions. If you have any questions you want to go over on the tests, like the previous tests. And then Wednesday is the final exam. Yes, so we're still meeting next week, yes. Okay, so notes 23 is Vertex of a Parabola, Applications and Modeling. So we're going to have to use what we learned in yesterday's notes in order to write these quadratics in vertex form. And if you remember, what we did is called completing the square. So we had to find some n value, where if we took that b value, divided it by 2, and squared it, that was going to help us get a perfect square. So again, we want to write them in vertex form. And vertex form is f of x is equal to a x minus h squared plus k. And remember, a told us if it was facing up or down. Also told us if it was going to be a fat or skinny parabola. What did h tell us?
The left or right horizontal.
Good, so the left or right shift, so that horizontal shift. And then what about k?
That was the y-axis.
Yeah, so either up or down or the vertical shift. Okay. So the first concept, we're going to practice writing a quadratic in vertex form. So typically what they're going to give us is a quadratic that is in standard form. So that ax squared plus bx plus c. And they want us to convert it to vertex form. Okay. So recall, in order to do this, I'm going to rewrite this. F of x is equal to x squared plus 8x plus 13. I need to write this as x squared plus 8x, leave some space for my n value that I need to find, plus 13, and then some space after, where I can either add or subtract the number that I'm finding for n. So to find n, we're going to take our b value, which is 8, and we're going to do 8 divided by 2 squared. So 8 divided by 2 is 4, and 4 squared is 16. So I'm going to write plus 16, which means on the other side of that 13, I need to write what? Minus 16. Okay, when I get to this part, I can now take those first 3 terms where I found n, and I can write this as a perfect square. So this is going to be x plus 4 squared, because I always use the value before I squared it, and yesterday we called it our star value. And then I simplify the like terms on the other side, and I get minus 3. 13 minus 16 is negative 3. So now I have this written in vertex form. Okay. If I don't see an a value there, I have to remember that that a value is what? 1. So if you need to write that there to remind you, you can, but you don't need to include it. Okay, so once we find this, then we're going to be able to answer the rest of the questions. So remember, we said in order to find the vertex, that was our hk value. Good, so our vertex would be -4, -3. Because our original formula for vertex has a minus next to the h. That's why we always choose the opposite. So since this was a +4, we chose a -4. And the k value doesn't change. Good, and for the axis of symmetry, which you would also see as AOS, is always going to be the x value of the vertex. So we write that as x equals -4. Okay, now it's saying find the minimum value. So it's not asking you to say, okay, is it a max, is it a min? It's telling you that it is going to be a minimum. And in order to find that minimum value, we are going to look at the k value. Okay, so our k value is -3, so that means our minimum value is -3. This is not a equation, so we did not have to write x equals or y equals. It's just a number. So that would be for range, if it's asking for range. So this is our k value. Okay. This is our h value. And then we said vertex was h comma k. Okay, so that is it for that example. Our next example says, given the function -2x squared plus 12x minus 16, first put it in vertex form. So I'm going to rewrite this down here. Okay. And before I start the process of writing this in vertex form, notice, what is my a value in the very front? -2. Okay, we don't want an a value there. That a value should be 1. So when I'm rewriting this, I'm going to write the -2x squared plus 12x, still with my gaps. But I need to make sure I take this first part and take out a GCF before I continue. So what would be that GCF?
12/2.
If we want...
I'm sorry, yes, the GCF.
Yes, but we would want that x squared value to be 1. Good, so we would take out a -2. So then I'm left with x squared minus 6x, which means that I am using that -6 as my b value to find my missing a value, or sorry, n value. So I'm doing -6 divided by 2 squared. -6 divided by 2 is
3.
-3. -3 squared,
9.
9. So I'm going to do plus 9. But on this part here, am I going to simply add 9?
No.
No. Because technically, what number is this when I multiply it?
It's 9 times 2. No.
-18. So really what I just added to that problem is a -18. So if I want to cancel that out, what am I putting here? A positive 18. Oops. Because the goal here is to add nothing.
Can you repeat the last one?
Yes. So once I found my n value, which was 9, in order to figure out this value, I have to first pay attention to the GCF. Well, this GCF of -2 is actually being multiplied by the 9. So this gives us -18. And if I want to essentially add 0, meaning I need to cancel out that -18, so I'm going to add positive 18.
And if that was negative, then it will be negative.
Correct. Okay. So then from here, I can write this in my vertex form. This is going to be -2, and then x, what's going to be in the blank here to make my perfect square? Remember, it's always the number that I square when finding my n value. -3. So it's always this value. We named it star. Okay, so this is x minus 3 squared, and then I combine my like terms on the other side. -16 and positive 18 is plus 2. So I went from standard form to vertex form. This is the same equation. If we were to graph it, you would see that this is visually the same exact function. we alter it to help us find the vertex. Okay. So from this, I think that's what the next question is. Yes, the next question is asking us to find the vertex, and that would be what point? 3, 2. So it'd be a positive 3, 2, because we always change the opposite sign here.
Yes.
Opposite sign.
Is that because it gets squared?
It's because if we look back at the formula, it's negative. So technically only a 3 got put in here. Okay, so we have h comma k, which we said was 3, 2. What would be my axis of symmetry? X equals 3, very important. Always put that x equals. Okay, always put the x equals. Okay. And the maximum value is going to be 2, because for the maximum or the minimum, we always look at what value? The k value. So in our k value here, in our vertex was 2, so that's why this maximum value is just 2. Do you write x equals 2? No. Okay, the only reason for axis of symmetry that we write as an equation, because recall axis of symmetry, if we have a graph, is going to be a line that cuts that graph in half. So it makes sense that it has to be an equation because we are drawing a line. Okay. Now they add in some other questions for us, and that is to find the x and y intercepts. So in order to find the x-intercept, you're always going to plug 0 into y. Always the opposite. So if you're finding the x-intercepts, you're plugging 0 into y. If you're finding the y-intercepts, you are plugging 0 into x. And the easiest way to do this is to not plug it into our vertex form. It's to actually plug it into our standard form. So our standard form, the one in the very beginning, before we started manipulating it. So f of x is equal to negative 2x squared plus 12x minus 16. We know that f of x is the same as saying y. So all I'm going to do is say 0 is equal to negative 2x squared plus 12x minus 16. And now we just have a standard factoring problem. So if we were to factor this, what would be our first step? GCF of negative 2. So 0 is equal to negative 2, parentheses x squared minus 6x plus 8. Okay, then we would use the AC method, and we need to find two numbers that multiply to 8 but add to negative 6. And what would be 2 and 4? Both positive, both negative. One positive, one negative.
2, negative 4.
So if it's a 2 and a negative 4,
Both negative.
yeah, they would both have to be negative, right? Negative 2 times negative 4 gives us positive 8, and negative 2 plus negative 4 gives us negative 6. So we would write this as 0 is equal to negative 2 times x minus 2 times x minus 4. Remember, I can go straight into the factors if my a value is what? 1. If it's not 1, then I have to do factor by grouping. So from here, in order to find my x-intercepts, I'm just going to plug and set each of these equal to 0. So I ignore the first part because does it make sense to say negative 2 equals 0? No. So then I go to the next one, x minus 2 equals 0, which means x equals 2. And x minus 4 equals 0 means x equals 4. So since these are the x-intercepts and we plugged in 0 for y, what we actually have is 2 points that we could plot. 2, 0 and 4, 0. These would be our answers. We would have to write our x-intercepts as points.
last time, the GCF, we don't care about the GCF, we just let it be?
Yes, because if you try to set it in the equation, negative 2 equals 0 is a false statement, which means we skip it. Okay, any other questions on x-intercepts? Okay. So y-intercepts, we do the opposite. So we're going to plug in 0 for x. And for these intercepts, we're always using the standard form, not the vertex form. So I'm going to rewrite that. F of x is equal to negative 2x squared plus 12x minus 16. And anywhere I see an x, I'm going to plug in a 0. So this is f of 0 is equal to negative 2 times 0 squared plus 12 times 0 minus 16. What's going to happen to those first two terms? They're going to go to 0, so they're gone, which means we have f of 0 is equal to negative 16. And since this is a y-intercept where we plugged in 0 for x, we would write this as the point 0, comma, negative 16. And that would be our answer. So after we find all of that, it's going to have us graph. And what's nice about this is that we have found everything that we can put on the graph in order to draw our parabola. So off to the side, I'm just going to write all the things that we should be plotting on our graph. So you need to make sure we plot the vertex, the x-intercepts, the y-intercepts, and the axis of symmetry. So once we plot all of those, we're going to be able to draw our graph, and it's going to be a lot more accurate than us creating that small table like we did on the last notes. Okay, so to make it easier, so I'm not scrolling up back and forth, what was our vertex? 3, 2. What were our x-intercepts?
2, 0, 4, 0.
Okay, 2, 0, and 4, 0. Y-intercept was 0, negative 16. And our axis of symmetry was x equals 3. Okay, so all that information that I found, I'm going to plot on here. Okay, so starting with let's go ahead and go by 2's because negative 16 is not going to fit on this graph. So going by 2's to do the vertex at 3, 2. So that would be right here. Okay, the x-intercept at 2, 0, 4, 0. So 2 and 4 because I went by 2's. Ah, I did something wrong. I did this. Yeah, I know. You guys are not going to say anything. You're just going to be like, yes, whatever you say. Okay, and then the y-intercept at 0, negative 16. So 2, 4, 6, 8, 10, 12, 14, 16. And then axis of symmetry at x equals 3. Is going to be a dotted line that goes down here. And then if we recall from the very beginning, that a value that we factored out for our vertex form, was that a positive or negative a value? Negative, so it's going to be facing down. So as pretty as you can draw it, right? As long as it's hitting all 4 points that we plotted, and we have the arrows at the end of our parabola. That tells us it's going on forever.
What if you know
So we do know that it's a maximum because we wrote that, but if you look at the vertex, we kind of already plotted the maximum, and that maximum value was at 2.
Yes, I'm sorry,
Yeah.
because y'all mentioned the H, the k value, right? Or H value to be -3.
The A value.
A value.
The
Okay.
A value.
Yes.
Yes, so the A value was less than 0, so that's how we know it was facing down. Yeah. Okay. There will be 2 problems like this on the test. Okay, where you're going to have to convert to vertex form, find all the questions, and then graph it. Yes.
Why did you plot the
What did I plot? What? Sorry?
vertex and the series?
Because I went by 2's.
Oh, okay.
I was counting by 2 so I could fit that -16 on there.
Oh, makes sense.
Okay. So next concept is the vertex formula. So let's say, yes.
Wait, but miss,
Mm-hmm.
in previous problems, we like went by 3 for like X and then 1 for Y.
Correct. I just went by 2's on both.
Okay.
Yeah, as long as you're consistent on one axis, like this entire y-axis, you have to go by a number. And then this entire axis, you have to go by a number. This time I just decided to do 2's on both. But yes, I could have done 1's on the x's. Mhm. So another way to find the vertex, instead of placing it into the vertex formula, vertex form, is to use the vertex formula. This is not common because this is a lot harder to memorize than it is to just memorize the steps of completing the square. Okay? However, just want to introduce it so you do see it. So the reason why it gives you 2 different versions here is one version is not using the function and the other version is using the function. So when you see this, we're going to use this version because we're always going to be given a function. This part right here is our x. So we still use the standard form ax squared plus bx plus c, and we're going to use the values of b and a to find our x value. Once we find that x value, we are going to plug it back into the function, and that is then going to give us our y value. Okay. Once we have that x and y value, we're given the vertex. So it's just another way to find the vertex. Okay. So again, this one's not as common. Okay, so it says, given the function, answer the following questions. It says, use the vertex formula to find the vertex. So I'm going to just rewrite it down here. So I can zoom in a little bit more. And just recall that since this is in standard form, we have our a value, which is 1, our b value, which is -2, and our c value, which is 5. The only ones we care about, though, is the a and b value. So in order to find x, I'm going to say x is equal to -b over 2a. Well, b is -2, so technically I have -2. And a is 1, so I have 2 times 1. Which means my x value is going to be what number? 1, because minus a -2 turns into a +2. 2 times 1 is +2. 2 divided by 2 is 1. Okay, that is my x value. In order to find my y value, I'm going to plug in 1 everywhere I see x. Okay, so y is equal to 1 squared minus 2 times 1 plus 5. So I'm using that h of x equation from the very beginning, and I'm plugging in 1. When I do that, I am left with 1 minus 2 plus 5, which gives me what value? Close, not quite. 4, right? 1 minus 2 is negative 1. Negative 1 plus 5 is 4. Okay, which means our vertex is 1, 4. So 2 different ways to find the vertex. You could either rewrite your equation in vertex form or use the vertex formula to find the vertex. Okay. Yes?
Why is it 4?
It's 4 because when we plugged in 1 to this equation, 1 squared is 1. Negative 2 times 1 is negative 2. And we bring over the 5, and we just add those together to get 4. Mm-hmm.
Is
Yes.
1 considered f, the f is a number?
Say that one more time.
How do we use 1? Where do we get 1?
1 was using this formula, the negative b over 2a.
So
Oh, forgive me, I see what you mean.
Mhm.
Oh, I see. So we plugged in what we found using that formula.
Yes, because this part of the formula, all it's saying is take what you found for x, this was x, and plug it back in.
Yeah.
And that's what we did.
we always use negative over 2, right?
Correct.
And this is equivalent to
That if we were to go back and actually put h of x into vertex form, we would get this vertex as well. So just 2 different ways. It just really depends on the question, like what is it asking and what's the fastest way to solve it. However, you will be reintroduced to this in the next course, as well as the vertex form. However, depending on your professor, I don't think a lot of them allow notes or like a formula sheet. So that's why people usually prefer to do completing the square for vertex form, because they don't have to memorize this formula. Okay. So still on this same problem, we found the vertex using that vertex formula. Now it wants us to find the x and y intercepts. So we're going to do that exactly the same. For the x-intercepts, we plug in 0 for y. For the y-intercepts, we plug in 0 for x. And we always use that standard form. So I have h of x is equal to x squared minus 2x plus 5. I just brought down the equation from the top. And since we're finding x-intercepts, we set y equal to 0. Well, anytime we see f of x, h of x, g of x, that's y. So we just say 0 is equal to x squared minus 2x plus 5. So then we use the AC method to factor, and we would need 2 numbers that multiply to 5 but add to negative 2.
Nothing multiplied by 5.
So it's saying no solution.
So it's not a no solution, but you are right. There is nothing that we can think of that multiplies the 5 and add to negative 2. But remember, we introduced imaginary numbers, okay? Which means we might not have a real solution, but we will have an imaginary or complex solution. And in order to find that, so we're going to put over here, okay, this is not factorable. If something is not factorable, you have to do the quadratic formula. Does that sound familiar to anybody? Maybe it'll be familiar once I write it. So I'm going to write the name, quadratic formula. And don't hate me, you're going to need some more space than what I gave you. But this is x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. And there's a wonderful song on YouTube, okay, that we would torture, enjoy with our students, the freshman students. And it is called the quadratic formula, Pop Goes the Weasel. And so it's a song that helps you memorize the formula. And I taught Algebra 2 last year. A lot of the algebra teachers would play this on repeat, like very low. So like while I was teaching, it was always playing in the background. During the test, it was always playing in the background.
It works. I still remember the song.
Yes, I will play it after the notes. It's too good. You're going to be falling asleep like singing this song in your mind. Why throw away 8 weeks of work just for the song?
Just over the song I've done.
Oh goodness. Okay. I'm gonna erase that, because I have the digital. I can do that. And I'm gonna plug everything in. So remember, we labeled A, B, and C at the very beginning of this problem. So I'm gonna use those values and plug them in. So this is, that is too large. Okay, x is equal, b is negative 2, so minus a negative turns into a positive. So this is 2 plus or minus the square root. B squared is negative 2 squared. So I'm going to write negative 2 squared minus 4 times a. What was a? 1. Times c, which is 5. Okay, all divided by 2 times 1, because that was our a value. So all we have to do is simplify. And when we simplify, what you're going to notice is that we had a negative under the radical. That's why it's not factorable, because we can't we can't reduce a radical that has a negative into a real solution. So simplifying this, I get 2 plus or minus the square root of 4 minus 20 over 2. Which is equal to 2 plus or minus the square root of negative 16 over 2. So when we get that negative under the radical, that is telling us that we now have an imaginary number. And what would this part be in terms of the imaginary number? 4i, because the square root of 16 is 4, and because we have the square root of negative, we know it's i. So this is equal to, change color, 2 plus or minus 4i over 2. Okay, can we reduce this in any way?
Yes. Can the 2's just cancel out?
No, you can't.
So not just the 2's cancel out. We would have to look at everything, the 2, the 4, and the 2. And they can all be divisible by 2. So that means we have 1 plus or minus 2i. Okay? Yes?
I had a problem like this on Addix,
Mm-hmm.
and then they just crossed out. And then they just left that next one.
Were they all the same number, though? Like, if they were all 2's, then you could do that. But yes, if Alex did that and it wasn't a 2, then it was wrong.
Yeah, I'm not sure.
Okay. Okay, so this is our x-intercepts. Okay, and what that tells you is that we're not really going to be crossing the x-axis. That's why we have that imaginary number there. Instead, it's going to be crossing some imaginary line above or below the x-axis. What's nice about the quadratic formula is, let's say you forget how to factor. Okay, The quadratic formula will always work. Okay, it will always work. So you could use it in replace of factoring, especially if you need to factor to solve. Okay, so that was the x-intercept. Any questions on that?
You can use what part?
So let's say they gave you this equation here and they tell you solve by factoring. Well, you wouldn't have to factor. You could use the quadratic formula and you would get an answer every single time. It doesn't always have to be an imaginary answer for it to work.
If we got an equation that was factorable, would it look like that answer? Or would it be like...
No, it would be like how we factored before. We got like 2 and 4. It would be evenly 2 and 4. Yeah, there used to be a whole lesson that we taught over quadratic formula, but they cut that out. So it's just a quick introduction to it. Okay, so now we're going to find the y-intercept, and the y-intercept is when x is 0. So I have h of 0 is equal to 0 squared minus 2 times 0 plus 5. What's going to happen to the first two terms? They're gone. We have h of 0 is equal to 5, or we rewrite that as a point 0, comma 5. Okay. Notice I didn't write my imaginary number as a point. Okay, it's very hard to plot an imaginary number when we're on a 2D plane. Okay, so typically they're not plotted. They're there to show the user that, okay, we solved it, but it's not something that we can easily plot. Okay, and you'll see why when we graph it in just a moment. So what are the things that we're always going to plot? What's the first one? The vertex. What's the next one? X and y-intercept. So in this case, we can't plot x-intercept, but we can plot y-intercept. And what's the last one? The AOS, axis of symmetry. So I'm going to start with the vertex. And remind me, what was the vertex? 1, comma 4. Okay, so I'm just going to go by ones this time. Okay, so 1, comma 4. 1, 2, 3, 4. That's the vertex. And then I can't plot x-intercepts, but I can plot y-intercept. And what was my y-intercept? 0, 5. So that's right here. And then I can do my axis of symmetry, which is x is equal to 1, which means it's a dotted line that passes through the vertex. And then if we look back at the very beginning, our a value was positive or negative? Positive. So is it going to be facing up or down? Up. Okay. So this is why our x-intercepts cannot be plotted, because does this parabola cross the x-axis? No. So technically, when we get these imaginary numbers here, so in our example, 1 plus 2i and 1 minus 2i, really it's crossing some type of imaginary plane up here, and it has these points plotted. Okay, that's where the imaginary number comes from. Okay, it's some imaginary plane, again, that is plotted, that crosses through those points there. This concept is important, but not important unless you're going to major in math. Okay. Then you go on further, right?
They did this with electrical engineering.
Electrical engineering? It's a great question. I don't know.
I got a quick question.
Not sure. Do you know what math you're supposed to go up to? Is it Calc 3?
No, just cancel.
No, then you're good.
Okay.
Yes.
It says, like, that's just the x-intercept, 1 plus 2, and visible, right?
Yes,
That's not like graphical, right? You can't like put that on the grid.
correct. That's why we didn't write it as a point and we didn't graph it.
Okay.
You still want to solve it because let's say you have this type of question on the test. You can't just stop and say not factorable, I'm not going to get a point. You're still going to go through the process of solving and you're still going to give me an answer. It's just not going to be plotted on the graph. I don't think there's one like this though on the test.
If there's the one forward, it's not like finish.
Yeah, correct. Okay. Okay, any questions on that concept? Yes.
Hearing so fast. So
Sorry.
5, not factorable, right?
So,
So
yes.
what do we do with it?
So since it wasn't factorable, all that means is we couldn't find two numbers that multiply to 5 and add to -2. Because there's only two numbers. It's only 1 times 5.
Right.
No way we could get -2. That's where we went straight to the quadratic formula.
Formula, and we replaced A and C with 1 and 5.
Yes.
Okay.
Yes. And then we just simplified it all the way until we got this answer over here. Since it had an I in it, we can't plot it.
Were we able to do the quadratic formula because the A is 1?
You can do quadratic formula all the time. The A value doesn't matter. It's one of those things that works every single time, but not a lot of people like to use it because it's very tedious. Okay? If they get factoring down, factoring goes a lot faster. The only reason to use quadratic is if you do have something that's imaginary. But if you like the quadratic formula, it will work every single time. Has no restrictions like all the other ones. Okay. Last concept is application problem. Okay. So we have fireworks are launched at an angle of 60 degrees from the horizon. The height of one particular type of display is approximated by the function h of t is equal to -16t squared plus 128 times the square root of 3t, where h of t is measured in feet and t is measured in seconds. First part says, how long will it take the fireworks to reach its maximum height? So before we attempt this problem, the best way to approach this is to first draw a diagram. Okay, so let's say, this is our ground where the person is launching the firework. Okay, this is where it's going to start. This is where it's going to end. And again, this part is the ground. So when you launch something, does it continue going up? Or does it eventually come down? So it would look like this. Go up and then come down. Well, if we need to find the maximum height and we were to draw a coordinate plane over this, that maximum height would be the same as us finding the what? The vertex. Yes, the vertex. Okay, so we are finding the maximum value, but in order to find that maximum value, if we're relating this back to quadratics, we are finding the vertex. And looking at this problem, since we have a radical in it, it's going to be a little more difficult for us to convert this into vertex form. So this is one of those instances where it's easier to just use the vertex formula. So recall that the vertex formula is -b over 2a and then f of -b over 2a. And since we're not dealing with x and y, we're dealing with h of t, which is feet, and time, which is seconds, this vertex of h comma k is actually going to be used to represent time and height. So this is us setting up the problem. Now that it's all set up, we can now plug in our values into the formula. So looking at h of t, what would be my a value? Negative 16, that's a. What about my b value?
128.
It's actually a little bit more than that. Square root of 3. Because notice how this square root of 3t is under one radical? Well, we could rewrite this as the square root of 3 times the square root of t by the properties of radicals, which means that our b value is going to be the 128 and the square root of 3. This is b. Because usually it's all the numbers in front of our variable. Okay, so we're going to use those values and plug them in. So we have negative b over 2a is equal to negative 128 square roots of 3 over 2 times negative 16. This is equal to 128 square roots of 3 over 32 because the negatives canceled. Okay. There's no way to simplify this besides your calculator. So this is where you'll go to your calculator, do 128 times the square root of 3, and then divide whatever you get by 32. Mm-hmm.
6.93.
It's 128 times the square root of 3, all divided by 32.
We can't do the square roots of 3.
You should be able to do, it's just the square root, it's not an nth root.
So like,
Gives us a decimal.
or square root of 3, then multiply the 128 by
Yep.
that.
Mm-hmm. Yes, you will get a decimal, and what's that decimal?
6.93.
6.93. Okay, notice after this, I didn't put equals 6.93. This squiggle equal stands for about or approximately. So this is approximately 6.93 because we had to round it to a decimal. And what would be the units attached to this? Seconds. So the question was asking us, how long will it take the fireworks to reach the maximum height? So we would say it will take about 6.93 seconds to reach the maximum height. That would be our answer. When we're dealing with application problems, typically our answer is a sentence.
And that was for the vertex?
That was to answer question A. Question A says, how long will it take the fireworks to reach the maximum? So really, we didn't find the vertex. We only found the h value of the vertex, the very first one. Okay. But don't worry, we are going to find the next one because the next question says, find the maximum height. So there's a difference between when is the maximum height versus find the maximum height. So in this first part, part A, we found h, which is the x value of the vertex. What we're going to do for part B, this next part where it says find the maximum height, is we're going to continue the process of finding the vertex by plugging in 6.93 into our equation. So everywhere we see a t, we're going to plug in 6.93. So remember, h of t is equal to negative 16t squared plus 128 times the square root of 3t. So this is h of 6.93 is equal to negative 16 times 6.93 squared plus 128 times the square root of 3 times 6.93. Let me make this a little larger. Okay, and then once you're done writing this, if you'd like to help me out with the calculator, what I would do first is I would square the 6.93. So if anyone wants to do that for me and tell me what you get,
Are you talking about the last part?
just this part.
Oh.
Say it again.
2.632.
Negative 16 times 2.232.
Yes.
2.632. 2.632. And that's after squaring 6.93?
Yes.
Wait, squaring it, it's the number.
Times
the number.
itself. Yeah, that's why I'm questioning.
Well, I did that and it was, hold on.
Well, it's a very long number.
Yes, but if it's 6.93 squared, it should be more than 36.
48.
Yeah.
More like
48. Okay, that looks a lot better.
Oh.
48. I think you took the square root.
Yeah.
Yes. 48, and then what were the two decimals after it?
0.2.
02. 4802 plus 128, and then I would simplify this part inside your calculator. 3 times 6.93. 2079? Okay. Does it round differently?
It's an exact decimal.
Exact one? Okay. So then what I would do on your calculator is I would then do the square root of 20.79.
4.559.
4.559, so 5.6. I'm just going to round it to 2 decimal places. Okay, then you should be able to simplify each of these. So go ahead and multiply the first one together for me and tell me what you get.
Negative 768.32.
Negative 738,
68.
68, and then 2 decimals after?
0.32.
0.32, and then the next one? 5 point, 583.68. Okay, and then add those two together.
Negative 184.64.
Negative 184.64. So did everyone get the same thing?
Yes.
Okay. But remember, we're talking about height. So could we have a negative height? No. So what do you think we should do with this answer? Not GCF, not square it.
Imaginary.
Nope. Throw it away. Nope, we're just going to take the absolute value of it. Because remember before when we would get two answers, when you say, okay, one doesn't work but the other does? Well, we're only given one answer here. And we know that the answer was going to end up being negative because of that negative 16 in the front. Okay, but since we are trying to find a height, we're going to just take the absolute value of that, which is going to turn it positive. So we have 184.64 feet. Okay. Any questions on this one? Okay, so again, we were able to do this because we're talking about a real world problem and we can't have negative feet. Okay. We have one more.
So you just repeat the number and.
Yes. Yeah, it just gets rid of the negative. Okay, so we have one more. You will need that whole space. We are going to, we're not going to cry. We're going to give a brief introduction, because remember, the whole point of this course is to introduce you all the topics that you're going to see there, so you're not completely lost. So we're going to do a brief introduction of substitution and elimination of two equations. Okay, if you recall, like when you took a class in high school, it was called systems of equations. Okay, don't worry, we're going to go through everything. So the reason why we have to use this is because we're still talking about parabola. We're still talking about a quadratic. And it's saying, write an equation for a parabola that passes through these 3 points. Okay, so we have to create a parabola that passes through these points. So we could do a lot of guess and check, and it would take us forever to find one that matches this. So instead, we use what is called elimination and substitution. So the first thing we're going to do is I'm going to label each of these X and Y, and I'm going to use different colors to separate them. Okay, if you don't have different colors, do X1, Y1, X2, Y2. That would be a way to make them unique to themselves. Okay, so I just labeled
Sorry, the name of the method?
substitution and elimination. So the reason why it's called substitution is we are going to take these values and substitute them back in to the standard quadratic equation. So recall that the standard formula for a quadratic equation is y is equal to ax squared plus bx plus c. Well, when we plug in x and y, we are going to be left with equations that are in terms of a, b, and c. So the first thing we're going to do is we're going to plug in 1 and negative 1. So I have negative 1 is equal to a times 1 squared plus b times 1 plus c. And we're not going to be able to get a numerical answer. Okay, we're just going to get another equation. And that's okay, that's the goal. So we have negative 1 is equal to a plus b plus c. That is our first equation. And I'm trying to color code it, so I did red because I chose red for the first two x and y. Okay, we're going to do the same thing with the next point, negative 1 and negative 5, but I'm going to use blue. So they have negative 5 is equal to a times negative 1 squared plus b times negative 1 plus c. This gives me negative 5 is equal to a minus b plus c. That is my second equation. So we're doing the substitution part of the process. Okay, and we're going to do the same process for that last point. And now we're plugging in 2, 4. So I have 4 is equal to a times 2 squared plus b times 2 plus c. So this is 4 is equal to 4a plus 2b plus c. And what we did is we created 3 equations that are all in terms of a, b, and c. So now the goal is going to be to eliminate one of these variables. Okay, so now we're on the elimination part. So this is like step 1. Now we're doing step 2. And we are going to try to eliminate B. We'll start with B. The reason why we're starting with B is that if you look at those 3 equations, notice how one of the B's is positive, that's in the red equation, and one of the B's is negative, that's in the blue equation. So what we're going to do is we're going to take that red equation, so -1 is equal to A plus B plus C, and the blue equation, -5 is equal to A minus B plus C, and we are going to add them down, which means the numbers get added together, the A's, the B's, and the C's. So I have -6 is equal to 2A. The B's are now gone because that was the goal, plus 2C. This is now equation 4. Okay, now that we got rid of B from the first 2 equations, we have to choose another equation to get rid of B, which means we can't use these blue and the red one again. We can't use them because that's what gives us this. So instead, we're going to have to do something with this purple, and then we have to pick either blue or red. So which one makes more sense to pick if we're going to cancel them out? The positive B or the negative B? The negative B. So we're going to use the blue one. However, if we were to add this down, would the B's automatically cancel? No. What would we have to do to the blue equation for the B's to cancel?
It has to be
Minus 2B.
times 2.
So we have to multiply the whole equation by 2. So we're still on step 2, we're eliminating B. So I'm going to use the purple equation, 4 is equal to 4A plus 2B plus C. And the blue equation, -5 is equal to A minus B plus C. But before I add them down, we want the B's to cancel, so we need to take this blue equation and multiply the entire thing by 2. So we're distributing 2 in. So my equation is going to be -10 equals 2A minus 2B plus 2C. Okay. Which means I'm no longer looking at this equation anymore. I am now going to add the purple equation to the new blue equation. And I'm going to add down. So I have 4 plus -10, which is, so I'm looking at this one, 4 and -10, -6, thank you, is equal to, and then I have 4 plus 2A, sorry, 4A plus 2A, 6A. The B's cancel exactly how I wanted them to. And then I have C plus 2C. Plus 3C. Okay, that is my 5th equation. Okay, now we're on to step 3. Do you kind of see what's happening here? We're slowly going to cancel until we're left with only one variable. Oops, 3C, I forgot the C. Which means we can solve for the variable and eventually plug it back in. Okay, so step 3. Now we are looking at these 2 equations that we just created. Okay. Our goal here is to choose to cancel one of the variables. We can cancel the A's or we can cancel the C's. It doesn't really matter. So go ahead and somebody pick one, A or C? C? Okay, so let's pick C. Which means in order to cancel the C's, one of them has to be negative and one of them has to be positive, and they have to be the same number. So what would we have to multiply this equation by and this equation by so we get the same number C? Good, the opposite. 1 by 3, 1 by 2, and we'd have to make sure 1 is negative and 1 is positive. So we would end up multiplying one of them by a negative number, not just a positive number. So that is our next step. So we said we're going to eliminate C. And so I'm taking negative 6 equals 2a plus 2c, and negative 6 equals 6a plus 3c. So I'm going to go ahead and multiply this first one by negative 3 and this second one by positive 2. That way 1 is negative and 1 is positive. Okay. So I get 18 is equal to negative 6a minus 6c. That's the first one where I multiplied by negative 3. And then I have negative 12 is equal to 12a plus 6c. Which means now if I were to add them down, will my c's cancel? Yes. So I have 18 minus 12, which is 6, is equal to negative 6a plus 12a, which is 6a. And notice I now have it in terms of one variable. So can I solve for that variable? Yes. Divide by 6, and I get a is equal to 1. That is my first answer. I found a. Okay, now that I found a, I can plug it back in to one of the equations that have a and c. And then I can find c. Then once I find c, I plug in a and c to the original one, and I can find b. So that's what I'm doing next. That is my step 4. I'm going to plug in a equals 1 to find c. And it doesn't matter which one. I'm just going to make sure I choose one of the original ones before I change them. We're almost done. We're almost done. So then, so we have negative 6 is equal to 6a plus 3c. You don't have to choose that equation. You could have chose the one above. Negative 6 equals 2a plus 2c. Okay, the goal is just to plug it into an equation that has a and only c. So this is negative 6 is equal to 6 times 1 plus 3c. So this is negative 6 is equal to 6 plus 3c. Oops, 3c. What would be my next step to get c by itself? Subtract 6, and I get negative 12 is equal to 3c. And my last step, divide by 3. So c is equal negative 4. There is my second answer. 2 more steps. This is one of those problems that doesn't it make you feel great solving it?
So then where did you plug in the 6? Did you just choose a random equation?
To plug in a and c? Or
To find out b. Wait, did you ever find out b?
well, we haven't found out b. So the next goal, the next step is to find b. Let's see. I'm running out of space too. So step 5 is plug in a and c to find b. This is when I go back to one of my first 3 equations. So the equation that I wrote in red or blue or purple. It doesn't matter which one. I choose one. Okay. So I'm going to go ahead and choose the very first one, the one I wrote in red. So that was negative 1 is equal to a plus b plus c. So I have negative 1 is equal to 1 plus b minus 4, which means I have negative 1 is equal to negative 3 plus b, because 1 minus 4 is negative 3. Add 3 over, so negative 1 plus 3 is 2. So B is equal to 2.
You could,
Add 3. So what I did when I plugged in my numbers, I did 1 minus 4, and I got negative 3. Then I add the 3 over to the negative 1, and negative 1 plus 3 is 2. So my very last step is to take all the values I found, A, B, and C, and plug them into the standard form for quadratics. So I'm going to go ahead and put my answer in this little box over here. So I had y is equal to ax squared plus bx plus c. Right, that's the standard form. This is step 6. And then I just plug them all in. So this is y is equal to 1x squared, so I just write x squared, plus 2x minus 4. That is my answer, which means if I was to graph this equation, it would pass through the points 1, negative 1, negative 1, negative 5, and 2, 4.